I appreciate you being at this meeting. Thank you for coming to the meetings. It was an interesting semester. This will be the very last time we see each other on Zoom. I will be an office hour though, if you want to ask questions next week. So let's record. Oh, math. 30. Today is the 14th. Let's see. I have just posted the final exam. And we're just going to work on examples, similar but different examples for that test today. So your test is on WebAssign. It is, I want to say 18 questions and should take about 2 hours, but it's due next week on Friday. I just want to put a side note that I have a goal to make sure that I finish grading quiz 2 by this Monday. I've started grading, but I've only gotten a couple done, so keep on doing it. That way you'll have a good idea of what your grade is before your final exam is due. I'll also try to update the grade books sometime next week. And last thing, before we do actual problems, is my office hour. It's Monday, Wednesday, Friday, from 3 to 3:45, and I'll be there next week. So next week is only office hour, no class meetings. Okay, so. First one. So I just have the test on the side. I'm just gonna make up problems that are similar but different. So we have actually, before we do examples, I can put up a list of the topics. So it's going to be pretty much a third exam. So we're going to wait. Topics. Sections. Okay. 3.6, 3.11. Big problems from 4.1, 4.3, 4.4. And then 5.2, 5.3, 5.4, 5.5. Okay, let's do h of x is going to be, let's do tangent of x squared minus 2x plus 1. Actually, that's right. Find h prime. Okay. Derivative of the outer function. 5 is the derivative of the inside function. So if I factor out a 2, 2x minus 2. And just be careful that, you know that this is an input of the secant squared function. It's not this piece times this piece. So if it helps, maybe write it like this. It would be 2 multiplied with x minus 1, and then multiplied with secant squared of that input. It's like inside. Next one is going to be a product rule. Cool. We'll do, let's do x cubed times let's put e to a 2 plus x. So we have f and g. I'm going to call f x cubed, this is g. I want f prime g plus g prime f. Okay, f prime is 3x squared times g plus g prime. So e to whatever power stays as e to that power, and then you multiply by the derivative of the inside, which is in the power, which is just going to be times 1 times x cubed. All right. 3x squared e to the 2 plus x plus e to the 2 plus x times x cubed. We're going to do a quotient rule. Let's make this h of x. H of x will be I'm just going to stick close to what the actual problem is. Let's do an x plus sinh of x over just sinh of x. Find h prime. Okay, this will be g. We're going to have low d high. So low is f, d high minus high, d low over the bottom squared. G prime f minus f prime g over g squared. I'm going to double check. F prime g minus f, g. Oh, they have an f over g. Well, okay, so it would be the bottom function times the top function's derivative. Bottom function is f times the top function's derivative. Subtract. Okay, it should be good. Never hurts to just Google it though. Okay, f is x is sinh of x. This derivative will be 1 plus cosh of x. Okay, minus this next term. This is all in the numerator. So this times this minus that times the derivative of that. Derivative of sinh cosh. And then divide everything by sinh squared. Okay, that power you can put between the parenthesis and that function. Don't put it on that parenthesis right here, because it kind of looks like x squared, but you want sinh squared of x. So your derivative looks like sinh of x times 1 plus cosh of x. I'm not going to super simplify it. You know what? Let's just start a new problem. Okay, but in your test, you do want to fully simplify your answer. Let's get some critical numbers. Let's see, I'm just going to make it really easy. 2x plus 6. Okay, so there's two things to look for. When f prime of x is 0 and when f prime of x is undefined. F prime of x is 2. Wait, let's make this squared. So our derivatives now 4x plus 0. And that's never undefined. You worry about being undefined if you like divide by x. So if you divide by 0, if you have some kind of imaginary value from square rooting something, but you're not doing that either. So I want 4x equals to 0. Then x will be equal to 0. So let's see. Enter your answers. That's it. Just the x value. Next one is just a graph of a function, and we want to find where it's increasing, decreasing, concave up, and concave down. Let's have a straight line and then go flat. And then we're gonna do a half circle. And then maybe over, down. Okay, increasing on open intervals. So then the slope of the tangent line is positive, it's increasing, which is occurring right here. Let's label this 1, 2, 3, 4. Let's call this 5. Okay, so from negative infinity to 1. And then we're not increasing or decreasing right here, it's just flat. Slope of the tangent line is 0. Slopes are positive up till about 3. When they hit 0, right at the top. And then you're decreasing, still decreasing, negative slopes that way. So that's where you were increasing, nothing happening here, increasing, then decreasing from 3 on. All of the slopes of the tangent lines should be negative after x equals 3. Let's do concave up and concave down. So I think of it like your function should be able to hold water. So it's on a tangent line. So it should be concave up from, I'm going to say it's negative infinity over to 1. Kind of check. I'm going to back up. I'm going to put a little bit of an arch in this graph. It's kind of more related to the graph that's on your test. So let's put this looking down in a space. Clearly concave down. Still increasing slopes. Like slopes were still positive right here. So still increasing right there. But concave down from negative infinity to 1. So where it's flat, it should, I think it's not concave up or concave down. Let's see, it's just a 0 slope. So we're going to go on over here and look at from 2 to 3. It's concave down. Oh, and still actually down over until you get to 4. And then it has like this inflection. Wait, still concave down. Okay, down onto positive infinity. Down, and then even though it kind of I'm trying to have this be an inflection point. But it goes like over. My graph's not very good. Okay, kind of changing the graph again. This will be an inflection point halfway. here, and then change right there. So it goes down into from 3 to 4. Actually, all the way back, down, 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 down. 2 to 4. And then up from 4 to 4.5. And then back down from 4.5 over. Okay, I want to go on to another kind of problem. Sweet. So these are L'Hopital's rule. Let's do just one of them. Let's do the limit as x goes to pi of, I think we did something like this already, but we're gonna have 1 plus cosine of x. Sine of x. Okay. So either you can think of the graph where sine goes through pi, goes through the point pi comma 0. Let's see, there's also over here at pi, you have cosine equal to -1 and sine equal to 0. So sine of pi is 0. Yeah, and then cosine is -1. You can think of the graph as pi here at -1. Cosine of pi equals -1. So you've got 0 over 0, which means use L'Hopital's rule. Okay, the limit as x goes to pi of the derivative of the top over the derivative of the bottom. Derivative of sine is cosine. That's a 0 plus derivative of cosine, which is negative sine. Okay, let's try putting that value in. Cosine of pi, cosine of pi was -1. You got -1 over 0. What I'm thinking is we do L'Hopital's rule again. Also, just letting you know, I'm making these ones up as I go, so I'm just kind of hoping that they work. Let's try it before giving up. Okay, derivative of cosine is sine. I think I'm just going to keep doing this. It's not going to work. think it's the value that we're approaching. Okay, I'm gonna stop and just go pick a problem from the book so that we can just actually do an example for L'Hopital's rule and move on. Okay. It's okay practice, but I don't think we're going to find an answer. Let's use this. Okay, cool. This will work. Not quite. Okay. Resort to an old exam. Okay, let's do this one. The limit as x goes to 1 of ln of x over sine of pi times x. Okay, it says use L'Hopital's rule when appropriate. So let's see if we need to use the rule. Put in 1, ln of 1 over sine of pi would be 0 over 0. So we will use the rule. As x goes to 1. Derivative of the top is 1 over x. Derivative of the sine of pi times x. We'll need a chain rule. Derivative of sine is cosine. Times the derivative of the inside, which is pi x, some number times x. Use that number. How do we want to do this? Let's just put 1 in now. I'm not even going to worry about rewriting this. So we'd have 1 over 1, which is fine. Cosine of pi times pi. That would be 1 over pi times cosine of pi is negative 1. Cool. This is a good. Okay, that was a bit better. Moving on. We want to make sure we do a few integrals before we go. So going to go on and evaluate the definite integral that goes from -2 to +1. Let's do 1 plus u over u to the 4th. So we want to write that as two terms. We're going to evaluate from x equals -2 to x equals, to u equals 1 of 1 over u to the 4th plus u over u to the 4th du. And just keep rewriting this. It's u to a -1/4 power. Just -4. U to the power of 1 minus 4. U to the -4. U to the -3. Okay. We're going to add 1 to the power and then divide by that number. So -4 plus 1 is going to get you to -3. Plus u to a -2 over -2. And evaluate from -2 to 1. So I'm going to set up the problem, but leave the rest for like if you want to try it on your own, but just to show you what the process looks like. You put in u equals 1, and then subtract putting in u equal to -2. Okay, 1. I feel like I should, let's rewrite it first, and then we're going to evaluate. So bring this down, and that makes the power positive. And that negative sign, I'm just going to put in the front. It just makes the whole term negative. -1 over 3 cubed minus 1 over 2 squared. Okay, so put in 1. And then minus putting in -2. So be careful with your negative signs. Just checking. Minus negative. And then just keep simplifying. Okay, this one will be an indefinite integral, which I'm kind of thinking we should do some u subs before, for sure. Okay, one kind of easy one, and then u substitution, and that's probably it. Actually, that's the same. Okay, so just get an antiderivative for each term as you go. Antiderivative of e to the x is e to the x. And the antiderivative of 1 over x is ln of x. Ln absolute value of x. minus 2 times x and plus some number c. Okay, use substitution. I think we'll try this one. All right. It's secant squared of x over tangent of x dx. Okay, and let u equal tangent of x. Okay, a derivative. Du dx is equal to secant squared of x. I like to solve for dx, so I'm going to multiply both sides by dx and divide both sides by secant squared. Du over secant squared. And I put this in place of that. And do my substitution for tangent x. So let's just use this. It's going to be an integral of secant squared over u times dx, which is du over secant squared of x. That is going to reduce to 1. And it's the integral of 1 over u du. Which would be an ln absolute value u plus c, and u was tangent x. Cool. I think we'll do one more before you go. Maybe a definite integral that also has a u sub. At least most of it will work through. Okay. So, last one. Exciting. I had a great time doing all this math. Can't believe it's almost over. Okay, we're going to do let's see. Oh, cool. Okay. All right. The integral from 0 to 1 of e to the x over 1 plus e to the x. We're going to let u equal 1 plus e to the x. U dx. So derivative with respect to x is going to be 0 plus e to the x. So du over e to the x is equal to dx. I've got my e to the x still there. 1 plus e to the x is going to be u. And then dx is du over e to the x. Okay, so it's another integral, but this time we're actually going to have to evaluate. So the integral from 0 to 1 of 1 over u du. And that's going to be ln absolute value of u evaluated from 0 to 1. And I would suggest that you get your expression back in terms of x. You can get these bounds in terms of u, but that's something we didn't really go over. It's doable, but we're going to just put u back in ln absolute value of 1 plus e to the x from 0 to 1. Okay, ln with 1 put in there with an absolute value of 1 plus e to the 1 minus ln putting in 0 ln of absolute value of 1 plus e minus ln absolute value of 1 plus 1. Just 2. That's good enough. Okay, so that should be enough practice for you to be able to do the final exam. I will be working on grading and updating the gradebook all next week. And if you have any questions, I'll be in office hour. So thank you for coming to class. Thank you for having done this semester online. And have a great summer break.